Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is just to go through some examples of solving right triangle problems. So basically, given a right triangle with maybe a side or an angle or maybe a pair of sides or something, what we need to be able to do is find all the missing sides and all the missing angles. I'm going to make kind of a twofer out of this. We're going to work two separate examples here, starting on the left here. So for now, just ignore this triangle over on the right. We're going to focus on just this one. So this is intended to be a right triangle there, so that's a 90-degree angle. We've got a 40-degree angle here, a missing side on the left, and a missing side right here. Also a missing interior angle. So the first thing we should do is give all of these unknowns names. So we might call this maybe, I don't know, maybe x, and then maybe this distance here, we'll call this y. And then this interior angle that I don't know, I'm going to call that maybe theta. I like to use Greek letters for my angles. Now, we know this 40-degree angle. We know the hypotenuse. So if we think about the different trig functions, I'm going to write down a couple of equations here. Sine theta is opposite over hypotenuse. Therefore, the sine of 40 degrees is equal to x over 10. Because x is opposite the 40, 10 is the hypotenuse. I'm going to go ahead and write another equation out, the cosine function. Cosine of an angle, of any angle, is the side adjacent over hypotenuse. So the cosine of 40 degrees is going to equal the side adjacent, which is what I called y. So cosine 40 equals y over hypotenuse, 10. What I have here is a pair of equations here that I can use to solve for x and y. So I'm going to take a moment and do that. I can solve this one by multiplying both sides by 10. So x is going to equal 10 times the sine of 40 degrees. And if you give me a moment here, and I get 6.43 out of that, approximately. Over here now, to solve this for y, we would multiply both sides by 10. So y is going to equal 10 times the cosine of 40 degrees. And I get about 7.66. Now, as a quick check by Pythagorean theorem, because this is a right triangle, x squared plus y squared has to equal 10 squared. I'm just going to do a quick check on that. 6.43 squared plus 7.66 squared is about 100, which is approximately 10 squared. Well, 100 is exactly 10 squared. This is actually 100.02. So this is my check here that my calculations are probably good. Now, to find theta, there's a couple different ways to find theta. In this example on the left, I'm going to make use of this fact. The sum of the three angles in a triangle have to add to 180. That means these two have to add to 90. So that allows me to write out this equation. 40 plus the angle that I called theta equals 90 degrees. I can solve that for theta, and I get 50 degrees. So at this point, this triangle is completely solved. Now, before we look at the example on the right, I'm going to talk about another way to actually find theta. So here's theta, and what I could have also done is this. I could have written down a trig function for theta. Now, once all three sides are known, I could use any trig function I want. I'm going to go ahead and use the sine function. The sine of the angle theta here is equal to the side opposite theta. That's this guy, which is y, which we found to be 7.66, divided by the hypotenuse, which is 10. And this is an equation now that I can solve for theta. And I'm going to go ahead and simplify it a little bit first. So we're going to sine theta equals, if I take 7.66 divided by 10, I get 0.766. Equations like this are solved by applying what's called the inverse sine function. If we were to take the inverse sine of both sides, if I actually write it out, it would look like this. Sin minus 1 of sine theta equals sin minus 1 of 0.766. And again, this sin minus 1, the minus 1 means inverse sine. And basically, and I'll make a video on this talking about more in detail, but basically if you take theta and then you take sine of theta and then the inverse sine of theta, you're back to theta again. And then your calculator will tell you the inverse sine of 0.766. If you're following along here, if you look at your sine button, and then usually you have to push a second button or something to get to your inverse sine button. But what I get out of this is 49.996, or basically 50 degrees, as we already knew. Okay, so I'm going to take this now, take all of this work, just move it over because I need a little room, all right? And now we're going to deal with this guy. I think I'll shrink that down just a little too. Okay, now we're going to deal with this animal. All right, so again, unknowns. I have an unknown angle. I'm going to call that theta. Another unknown angle. I'm going to call that alpha. And an unknown side. Since it's the hypotenuse here, I'm going to go ahead and call that h. Now, I'm going to go ahead and start by finding theta. Now, since we don't know alpha, we can't use the fact that they add to 90. I'm just going to use the tangent function, noticing that I know the 7 and I know the 12, opposite, adjacent. I'm going to write out the following equation. Tan theta is equal to 7/12. And again, similar to this step right here, theta then is going to equal the inverse tangent of 7/12. I'm going to go ahead and take a moment and do that. I get 30.256. I'm going to round that to 30.3. Yeah, you know what? I'm just going to say approximately 30. So I know that this angle is approximately 30. Now I'm going to use the fact that these two have to add to 90. So our 30-degree angle plus alpha has to be 90. So if we solve this for alpha, we get 60 degrees. Again, approximately, because I rounded a little bit. All right, now to find h, the hypotenuse, there's lots of ways to find h. We could use Pythagorean theorem. H squared has to equal 12 squared plus 7 squared, or we can use any trig function we want. I'm going to go ahead and use the cosine function. The cosine of the angle theta is equal to 12 over h, because 12 is adjacent, h is the hypotenuse. Multiply both sides by h. Therefore, h is going to equal 12 over cosine theta. Now, theta we found to be 30 degrees, so 12 over cosine 30. Take a moment and calculate that. .9. Again, approximately 13.9. Again, I did a little rounding earlier in this problem, so if it doesn't match up exactly, that would be why. We can use a quick check here. 12 squared plus 7 squared is equal to I got 193 out of that. And I'm going to check that against 13.9 squared. Keeping in mind I rounded a little bit. Oops, okay. Okay, I get 193 when I take 13.9 squared. 193.21, and just a quick check here again, 12 squared plus 7 squared, 193. It looks like 19 to the third, but 193. And then 13.9 squared, 193. Again, we also could have used Pythagorean theorem to find h. We could have written the following equation, h squared equals 12 squared plus 7 squared, and solved for h that way. So, again, the point of this video was how to find the missing sides and angles for a right triangle. I went through 2 examples here. Hopefully these make sense. Have a great day.